Hello, my name is Frédéric Perra, and I'm recording this video to highlight some of the changes that I've done to Quest. So firstly, there was a small bug which we fixed. So just to show what this bug actually did, is here I have two identical spectra on Quest version 1.1.2 on the left and 1.1.3 on the right. And so you have two sites of equal intensity. However, if for one of these sites in both cases I include a non-zero chemical shift anisotropy with a non-coincident principal axis frame as that of the electric field gradient tensor, and do the same thing on both versions, then you can see that on the left-hand side now, the spectrum which span was included in has actually a reduced intensity, has actually an increased intensity, by a factor of 4, and that's because that when you have two different principal axis systems, you need to pattern average over a hemisphere, whereas if you only have one principal axis frame, then you only need to average over an octant of a sphere. So 4 times more pattern averaging is necessary when you include this CSA, and so the intensity actually ends up being 4 times higher. In the newer version, this is being corrected, where you can now see that the intensity of both sites is still correct. And so you would get the correct results if you include multiple sites, some of which having CSA and some of which having not having any CSA. Additionally, I've made a major speed boost in Quest. So the way that the pattern averaging is done in Quest is that you separate space into a bunch of different triangles, and you do a linear interpolation, and you have to step through all the different data points in your spectrum and calculate, okay, what's the intensity that you should have at this part of the spectrum. But for most cases, there's actually no intensity in that particular bin for any 3 frequencies that you're interpolating from. And so if you just filter out all these cases where you basically add 0, then you speed up by about a factor of 10. So the newest version of Quest is significantly faster. And I've also included some parallelization of the code in version 1.1.3p. So if you're using a computer with multiple cores, that version would be faster than 1.1.3. However, if your computer only has a single core, then it's probably better that you get the one without the parallelization, since that would be faster on your computer. And so basically, this newer version of Quest with the parallelization is about 20 times faster than the first version of Quest which we released. And so if you want to calculate a spectrum which in version 1.1.2 would take about 10 seconds, it would take under a second to calculate it with this newer version of Quest. So just to show this, for example, if I use a very large pattern averaging quality of 250 on the spin 3/2 NMR spectrum, you can see that the spectrum is calculated in a very short amount of time, about 1 second. And so basically, now you can calculate these exact NMR spectra in basically the same amount of time as it would take to calculate perturbation theory NMR spectra. So if you're interested in downloading this newer version of Quest, you can do so by going to my supervisor, David Bryce's website. And thank you for watching the video.